Welcome back to Data Explained. In this episode, we're tackling one of the most important reasons your queries are either lightning fast or painfully slow: database indexes. Over the next few minutes, we'll unpack how databases manage to find a single row among millions without actually reading them all, and why understanding this one concept can transform the way you write SQL. So, let's start with the pain point. Imagine you have a users table with 50 million rows, and you ask the database to find someone named Anna. Without any help, it does exactly what you dread. It walks through every single row, one by one, until it finds her. That's a full table scan, and it gets slower as your data grows, burning CPU and disk on every query. So the natural question becomes, what if there were a shortcut, a way to jump straight to the right rows? That shortcut, as you might have guessed, is an index. So let's pin down what an index actually is. In one sentence, it's a separate sorted lookup structure that the database maintains right alongside your table, with pointers back to where each row actually lives on disk. That sorted order is the secret sauce. Instead of scanning 50 million rows, the database can jump almost directly to Anna, turning a slow scan into a quick targeted lookup. Here's the analogy that makes this click. Imagine you're hunting for every mention of TLS in a 900-page book. You wouldn't read it cover to cover. You'd flip to the index at the back, find TLS sitting in alphabetical order, and it points you straight to page 4 to 12. A database index is exactly that. The book's pages are your table rows. The index pages are the lookup structure and the key maps right to a row location. You flip, you don't scan. Now let's put the two approaches side by side. Without an index, the database walks row by row, 1, 2, 3, 4, 5, and only finds the match after checking every entry. That's linear time, O of n, and it gets painful fast as the table grows. With an index, you consult the sorted keys, jump straight to the row's location, and you're done in roughly logarithmic time. Same answer, dramatically less work. So how does that fast lookup actually work under the hood? Most databases organize their indexes as B-trees, balanced trees that keep keys sorted in tiers. You start at the top, ask a simple question: is my key before or after M? And follow the branch: AF, GM, or NZ. Each hop eliminates a huge chunk of the data, so even with millions of rows, you're only a handful of steps away from the one you want. And here's the good news. Putting that beast tree to work takes a single statement. You've got a query filtering users by email, which without help means scanning every row in the table. One create index on the email column, and the database builds that sorted lookup structure for you behind the scenes. The exact same select now jumps straight to the match. No code changes, just a dramatically faster query. But before you go sprinkling indexes on every column, there's a trade-off worth understanding. Yes, reads on the indexed column get dramatically faster. That's the whole reason we're here. But every insert and update now has to maintain that index too, which costs write time and disk space. So read-heavy workloads love indexes, but indexing everything just in case will quietly slow your writes to a crawl. With that trade-off in mind, it helps to know that not all indexes are the same. Different shapes solve different problems. The B-tree is your default workhorse, brilliant for ranges and sorted lookups. A unique index does double duty, speeding up reads while guaranteeing no duplicates, perfect for something like an email column. Composite indexes cover several columns at once, and then you've got specialists: hash indexes for exact match lookups, and full text indexes for searching inside the text itself. Let's zoom in on composite indexes because there's a subtlety here that trips a lot of people up. Think of an index on last name and first name like a phone book. It's sorted by last name first, then first name within that. So a query, filtering by last name flies, and last name plus first name is even better. But search by first name alone? The database has no shortcut. It has to scan everything. Column order in a composite index isn't cosmetic. It defines what queries can actually use it. So, which columns actually deserve an index? Reach for them on the things you filter by in where clauses. the foreign keys you join on, the columns you sort with order by, and anything that needs to stay unique. On the flip side, don't bother indexing tiny tables where a full scan is basically free, columns nobody queries, or low variety fields like a yes/no flag. The index barely narrows anything down. And be careful on write-heavy tables. Every extra index is more work on every insert and update. Now, once you've added an index, how do you actually confirm the database is using it? Don't guess. Ask. Stick explain, or better yet, explain analyze in front of your query, and the database hands you its plan. If you see index scan using followed by your index name, you're golden. That's the fast path. If you see sec scan, it's reading the whole table row by row, and that's your signal to investigate. Now that you can verify what's actually happening, let's clear up a few myths that trip people up. First, more indexes don't automatically mean faster. Every index you add slows down writes and eats storage, so piling them on can backfire. Second, an index only helps queries that actually use it correctly, which is exactly why explain matters. And third, the database isn't doing all this for you. Primary keys get indexed automatically, but everything else, that's a deliberate choice you make based on the queries you really run. And to really feel why this matters, look at how it scales. At 1,000 rows, honestly, it doesn't matter. A full scan is instant either way. At 100,000, you start to notice the lag, but push it to 10 million rows, and a full scan turns into painful seconds of waiting, while the index lookup stays effectively instant. That gap right there, that's the difference your users actually feel. So before we go deeper, let's quickly meet the toolkit you'll actually be using. Create index is how you add one in SQL. Explain shows you the query plan the database intends to use. And explain analyze goes a step further by running it and giving you real timings. Then there's the slow query log to spot what needs optimizing. PGRStat user indexes to check whether your indexes are even being used, and visual tools like SysAdmin or DataGrip to tie it all together. With those tools in hand, let's pull the big ideas together. An index is really just a sorted shortcut to your rouse. It turns a slow full scan into a fast, targeted lookup. Most of the time, you're working with B trees, which shine for equality, ranges, and sorting. Just remember the trade-off. Faster reads, but slower writes and extra storage. So index the queries you actually run and always verify with explain. So how does this look day to day? Start by finding the slow query. Your slow query log or app metrics will usually point straight at the culprit. Run explain to see whether it's doing a full scan or a clean lookup. Then add a targeted index on the columns it filters or sorts by and measure again, both to confirm the read got faster and to make sure your writes didn't pay too steep a price. If indexes clicked for you, there's a whole series waiting in the same spirit. Data Explained walks through SQL versus NoSQL, ACID, sharding, and caching, each one unpacked the same way we just did here. And when you're ready to push further on Postgres specifically, tuning it, securing it, running it well in production, there's a dedicated course over at Dargslan.com courses. Before we wrap up, I want to hear from you. Have you ever fixed a painfully slow query with just one well-placed index? That moment when something that took 8 seconds suddenly returns in 8 milliseconds. It never gets old. Drop your best index win in the comments. I read them, and honestly, those stories are some of the best parts of doing this series. And that's a wrap on episode 2. If indexes finally clicked for you today, hit subscribe so you don't miss the rest of the Data Explained series. We've got query planners, joins, and transactions all coming up. You can also find more deep dives over at dargslan.com. Thanks for spending this time with me, and I'll see you in the next one.